Imagine stepping out of a submersible at the bottom of the Mariana Trench. It's the deepest point on Earth, a place less visited than the moon.
You open the hatch and step onto the silt. But before your foot even touches the ground, something truly catastrophic happens to you.
We're talking about an environment so extreme, it's actively hostile to the fundamental chemistry of human life. This is the ultimate physics breakdown.
What exactly does 8 tons of pressure per square inch do to the human body? Does it look like a cartoon? Or is it much, much worse?
The answer is messy. Welcome to a deep dive into biology, physics, and why you should absolutely stay in the boat.
To understand what happens at the bottom, we first have to understand the descent. Water is heavy, really heavy.
At sea level, you have 1 atmosphere of pressure, about 14.7 pounds per square inch, pushing down on you right now. Every 33 feet you travel down into the ocean, add another full atmosphere of pressure to your body.
By the time you reach 1,000 feet, the twilight zone, the water is already pushing on you with 30 times normal atmospheric force.
At this depth, your ears would instantly pop, and any trapped air in your sinuses would compress painfully.
Keep dropping down to 13,000 feet, the abyssal zone, and the water turns pitch black. The temperature drops to near freezing.
And at 36,000 feet, the bottom of the Mariana Trench, you hit the absolute limit, 1,000 atmospheres of crushing force.
Now, let's address the big one, implosion. While crushing is slow, implosion is the precise physics term for what happens next. Remember that 8 tons of force? It's not just squeezing weak point. It's specifically air pockets looking at your point. Specifically, any air pockets inside your body. The lungs, filled with 1 atmosphere of air, are instantly pulverized as the pressure equalizes. They don't just collapse, they are effectively gone.
But what about the rest of you? You're mostly water, and water doesn't compress much, right? Technically, yes.
But the pressure is so intense, it actively targets the fundamental architecture of your cells. If the very blueprint is being corrupted.
It forces cell membranes to become rigid and brittle, turning flexible lipids into fragile glass. Fragile glass. Even essential proteins, the machinery of life, get physically squeezed and lose their shape, shutting down basic metabolic functions.
So how do deep-sea creatures like the ethereal snailfish live down there without being turned into car close-up soup?
Evolution had thousands of millennia to cook up an extreme solution. And the solution is specialized chemistry.
Deep-sea animals stabilize their cells using high levels of specialized molecules, particularly traplymethyl aminade N-oxide, or TMAO. Think of TMAO as anti-crush armor. It stops water pressure from distorting the crucial shape of their proteins.
If the pressure somehow didn't kill you instantly, the environment surely would. First up, total darkness. Below 3,300 feet, you are in the midnight zone. Sunlight never reaches here. It is colder than your freezer.
And then come the residents. Deep-sea creatures aren't terrifying because they're monsters. They're terrifying because they are perfectly adapted.
If you somehow survived the implosion and the freezing cold, you wouldn't be alone for long.
Scavengers like hagfish and zombie worms make short work of any organic matter that hits the abyssal plane. You would be recycled instantly.
So, what actually happens to your body at the bottom of the ocean? Total physics dominance.
The Mariana Trench is an active reminder that human biology is optimized for a very thin sliver of life on Earth's surface. Drop your answer in the comments, and don't forget to hit like and subscribe for more extreme physics and weird human biology breakdowns. If you loved this science animation, check out our previous videos on survival and history right now. History. Thanks for watching. Stay curious, stay curious, and see you in the next episode when we stay safely in the boat.